Hello everyone. Hello. Am I audible and visible to everyone? Can I get a thumbs in the chat box if I am visible and audible to everyone in the class? All right. Am I? Am I audible, guys? I hope I sound clear, right? Alright, so we are here with an excited part that is our question paper discussion of 2024 and I'm going to discuss the set 1 of that question paper. Okay, so there's no one in the comment box. Is there anyone? Can I get a thumbs in the chat box if you guys are there? Any trouble, ma'am? Alright, so my name is Christina, as you might be already knowing, right? And I'm from the Department of Chemistry, and we are the Ghost Corps, and we are the fastest growing edtech in GCC. And our main aim is to provide the quality education for all. And you guys will be excited as I am because the boards are on the doorstep, right? Okay, it's on the doorstep, and we don't have much time to go to the exam, right? So let's go with the previous year question, which will be helping you to know how the questions might be appearing on the question paper, and it will be giving you a good practice before the boards, right? So I'm going to deal with the chemistry, not the physics and the biology, and the physics and biology will be taken by other teachers. Now we'll discuss about the chemistry part of this question paper, okay, which plays an important role, correct? Now let's go ahead without wasting time. Let's go ahead with the first question that we have from the set 1 paper, and that is from the section A. You might be knowing what contains the section A, right? It's the MCQs which will be carrying 1 mark for each. 1 mark for each. Okay, if you pick the right answer, you will get 1 mark in your pocket. Here we go with the first question. When 2 ml of the sodium hydroxide solution is added to few pieces of the granulated zinc in a test tube and then warmed, the reaction that occurs can be written in the form of a balanced chemical equation. So you have to write the balanced chemical equation, as I repeated in all the lives, that zinc in the acid, which is the most important part, okay, or zinc in the alkali, which is again an important part that you have to concentrate on. There will be one or other question related to this. So make sure that you learn the equations related to this, where zinc is dropped in the sodium hydroxide solution. Okay, sodium is dropped in sodium is dropped in the zinc is dropped in the sodium hydroxide solution, that is your NaOH. Okay, zinc in the NaOH solution, what do we get? What do we get if we dip the zinc in the NaOH solutions? Definitely you're going to get the sodium zincate. And what is the formula that you can give for the sodium zincate? That is Na2ZNO2. I have seen many students who is making the mistake in the formula of zinc sulfate. It is Na2ZNO2 along with the hydrogen gas. Always remember, zinc when dipped in the acidic solution or the alkaline medium, hydrogen gas will be produced. Zinc or any metals, hydrogen gas will be produced for sure. Okay, now time to balance the equation. Balancing chemical equation is the most important part. We have 2 Na, so 2 NaOH. Can you find the option given right over here? Okay, so which is the, okay, thank you. Okay, so which is the correct answer? Which is the correct answer? That is your 2 NaOH and zinc, Na2ZnO2. So option B is the right answer. I hope everyone got the right answer. Correct? Okay. Now we'll go with the second question. That is right over here. Okay. Select from the following a decomposition reaction in which source of energy for decomposition is light. Before getting into the question, I have a question to ask. What do you mean by the decomposition reaction? What is decomposition reaction? Can you all let me know in the comment box what is decomposition reaction? Decomposition reaction is nothing but where we'll be having a reactant which will break down into 2 or more products, that is decomposition reaction. Decomposition reaction can happen in many ways. It can use the light energy, It can use the heat energy. It can even use the electricity for the decomposition. Correct? Now, there are set of reactions given over here where you have to learn the examples for each. Okay. Now coming into the first one, FeSO4 is decomposing into Fe2O3 sulfur dioxide and the sulfur trioxide. Okay. That's a perfect example that you can give for the thermal decomposition. This decomposition happens in the presence of the heat. If you heat, then this reaction will happen. Okay, so that's an example for the thermal decomposition. Now coming into the second one, H2O will be giving you H2 and O2. Okay, so that's the decomposition of the water. Perfect example for the electrolytic decomposition. Coming into the third one, AgBr is decomposing into silver and the bromine gas. That's an example for the photolytic decomposition. The decomposition takes place by the use of the light. Okay, so that is the answer that we have to choose. Okay, so that's the second the option C. And coming into the last one, calcium carbonate. Calcium carbonate, when we heat, we'll get the calcium oxide and the carbon dioxide. We learned this equation multiple times, and that's an example for the thermal decomposition. So option C is the right answer for the second one. Moving into the third question. Okay. All right. Now, a metal and a non-metal that exist in the liquid state at the room temperature are respectively, which is the only one metal which is existing in the liquid state at room temperature. Okay, so at room temperature there is only one metal which is in the liquid state. Everyone knows that it's mercury. And which is that only one non-metal which is present in the liquid state? We have only one at room temperature. That's the bromine. Mercury and bromine is the right answer. Mercury and bromine, that is your option C. Okay, mercury and the bromine. These are some exceptional cases in chemistry. The examiners will be always interested to ask the exceptional cases. So make sure that you learn all the exceptional cases. Okay. Now we'll go with the fourth question that we have. Here we go. Carbon compounds are good conductors of electricity. Is that a true statement? No. The carbon compounds are not that a good conductor of the electricity just because they don't have any free ions. They have the covalent bonds, right? The electrons are shared between each other, so there is no free ions or the electron present over there to conduct the electricity. And this one exceptional case, that is graphite. Okay, graphite is an exceptional case over there. Apart from the graphite, everyone are not that a good conductor of electricity due to the absence of the free electrons or the ions. Okay, now coming in the second one, are bad conductor of electricity. That's correct. That makes sense. Okay, so they are the bad conductor of electricity, have strong force of attraction between their molecule. No. Actually, compared to the ionic bond and the covalent bond, ionic bond is much stronger than that of the covalent bond. Covalent bond is comparatively weaker. Okay, it's weaker than the ionic bond. So that is not a correct statement. The strong force of attraction, no. They have the weak force of attraction between their molecule. Actually, the second and the fourth statements are very much correct. So which will be falling into the option? Are you able to find it? 2 and 4. Here we go. That's again the option C. Okay, have you noticed on everything that we have discussed was just the option C? Why? All right, just random things, I guess. All right, moving into the next question. Consider the following compounds. We have FeSO4, CuSO4, calcium sulfate, and NaCO3. The compounds have maximum number of water of crystallization. Okay, we have to check the water of crystallization. That's nothing but the number of water molecule present per the unit volume. Okay, so that's nothing but the water of crystallization. Let's go ahead with the FeSO4. Okay, actually it is, the formula is FeSO4 7H2O. The water of crystallization is 7. Okay, so what do we commonly call this FeSO4 S7H2O as? It is the green vitriol, because this FeSO4 has a green color. It's also called as the green vitriol. Okay, next comes the copper sulfate, that is CuSO4. Actually it is CuSO4 5H2O. Okay, CuSO4 5H2O. CuSO4 5H2O, which is called as the blue vitriol, and the water of crystallization is just 5. Now coming into the third one, that is calcium sulfate. It can be calcium sulfate hemihydrate or calcium sulfate dihydrate, that is gypsum and the plaster of Paris. Okay, so it is half or 2. I'm going ahead with the gypsum, that's 2H2O. Okay, now followed by you have the Na2CO3, 10H2O. Have you ever heard about this? Of course, that is the washing soda, correct? That's the washing soda, Na2CO3, 10H2O. Okay, so which will be having the water of crystallization of 10, and the maximum, they're asking for the maximum number of the water of crystallization, that is Na2CO3. Hold on for a second. I'm sorry for the interruption. Let's carry out with the next question. Okay. All right. Oxides of aluminium and zinc ore. Okay, aluminium. I have explained this many times, I guess, in the lives, right? So if you want to get the detailed explanation of that, you can watch our previous videos. You can watch our previous videos where I have done many examples of this. Okay, so this zinc and the aluminium. Okay, the oxides of the zinc and the aluminium can react with the acid and the base. Okay, or it can act as the acid as well as the base. Such oxides are something you called as the amphoteric oxides. Of course, you have to learn the reactions of both of them, where they react with the acid and the base. I have detailedly given the explanation in the previous videos, where you can check it out. Okay, just check it out, our revision classes for the grade 10. You will find the reactions, okay, for that with the detailed explanation. Okay, so just don't forget to check it out. Now coming into the next question. Okay, next question. Actually, we have 7 questions from the chemistry part. Okay, so coming to the second question, 7th question. MnO2 plus 4HCl gives MnCl2 plus 2H2O and the Cl2. The reaction given above is a redox reaction. Okay, what do you mean by the redox reaction now? Okay, what do you mean by the redox reaction? Redox reactions are really simple, where the oxidation and the reduction happen simultaneously. Okay, for a reaction, if the oxidation and the reduction happen simultaneously, we call that as the redox reaction. Always remember that for a substance to undergo oxidation, it should gain the oxygen. Okay, it's gaining the oxygen, or it is the removing the hydrogen. Okay, it is the removing of the hydrogen or the removal of electrons. That's what we call as the oxidation. Okay, if a substance is gaining an oxygen or removing the hydrogen or removing or giving out an electron, which is called as an oxidation. Okay, now what will be the reduction now? Reduction is the substance which gains hydrogen, not the oxygen. Okay, it gains the hydrogen. Gains the hydrogen or remove the oxygen or gains the electron. Just the opposite of the oxidation. Okay, oxidation and the reduction like almost similar, but it's just the opposite things. If you learn the oxidation, you can easily write down what is reduction. Okay, now coming into another important topic that I want to explain right over here is the reducing agent and the oxidizing agent, where the many students makes a mistake right over here. Okay, oxidation. Okay, the substance which is undergoing oxidation is the reducing agent. Okay, understand that first. Now the substance which is undergoing reduction will be acting as your oxidizing agent. Okay, this many things must be remembered in the case of the redox reactions. Okay, now coming into the example given right over here, MnO2 is turning into MnCl2, where they have removed the oxygen. Okay, removal of oxygen is what you called as the oxidation. Correct. Now HCl is turning into Cl2. Okay, HCl is turning into Cl2. Indicates that it is removing an hydrogen from here. Okay, so I'm sorry. Did I do the opposite? Okay, I'm really sorry for that. Okay, so removal of oxygen is what you called as the reduction. Okay, removal of oxygen what you called as a reduction. Okay, I just said the opposite. I'm really sorry for that. Okay, now HCl is turning into Cl2. Okay, where the hydrogen is getting eliminated. Okay, or the removal of the hydrogen is what you called as the oxidation. It's really simple that MnO2 is the one which is undergoing reduction to form MnCl2. HCl is the one which is undergoing oxidation to form the Cl2. Done? Which is really much simple. And can you find out who's the reducing agent and the oxidizing agent? Just out of the box, just out. Okay. So oxidizing agent is the one which is undergoing reduction. That is your MnO2. HCl is the one which is undergoing oxidation, which will be acting as your reducing agent. Okay. Now coming into the question. MnO2 is oxidized and HCl is reduced. No, it's not correct. HCl is oxidized. That's correct. MnO2 is reduced. That's again correct. Since it's a redox reaction, you have to involve both of them where the MnO2 is reduced and HCl is oxidized. That will be your right answer. Okay, that will be a right answer. Okay, any doubts so far? Any doubts so far? Nothing, right? And if you find anything difficult or any doubts, you can appellate, just ask me in the comment box where I will be reading. Keep on reading the chat box where you can ask the doubts. Okay, and then you have one assertion reason question from the chemistry part. There will be only one assertion reason for the chemistry. Okay. Now, hydrogen gas is not evolved when zinc reacts with the nitric acid. Again, in the short questions, I have given this because that's an important part of the chapter where we know that when the metals reacts with any acids, it will be producing the salt and the hydrogen gas. But there is an exceptional case of the nitric acid HNO3. When the metals react with the nitric acid, remember that it's not the hydrogen gas which is evolved over there, it's the water molecule. The water will be produced. What is the reason behind that? What's the reason behind that? The reason is just this. Okay, nitric acid oxidizes the hydrogen gas produced to the water. Okay, nitric acid is acting as a reducing agent. Okay, oxidizing agent which oxidizes the hydrogen into water, which itself undergoes reduction into like nitrogen dioxide or nitrogen monoxide. Okay, so your nitric oxide is acting as an oxidizing agent. Hydrogen gas will be evolved, but our nitric acid will oxidize the hydrogen gas which is produced over there into water. Okay, that's exactly why there's no hydrogen gas left. It's all the water. Okay, so that's a example that you have to learn. Okay, so assertion and reason, both of them are the correct, and reason gives the correct explanation for the assertion. That is your option A. Okay, that's your option A. Any doubts on this? Any doubts? Anyone in the class? No, right? We'll move into the next question now. That is your section B. Name the type of chemical reaction in which calcium oxide reacts with water. Justify your answer by giving the balanced chemical equation for the chemical reaction. Have you noticed one thing in the first question where we had, remember that question? It's the same paper, okay? It's the same paper. Where was that? Let me check it out. Okay, here we go. Oh, it's different. Okay, I'm sorry. I thought it's the reaction with the water. Okay, it's the reaction with the water. No, it's not. Okay, I thought the same question was repeating in the first part. No, it's not. It was the reaction with the uh, carbon dioxide. I'm sorry for that. Okay, now coming into this, calcium oxide reacts with the water, which is a real important part. Okay, where we have the calcium oxide. Okay, calcium oxide reacts with the water molecule. Reacts with the water. Okay. Okay, reacts with water. Calcium oxide reacts with water. Actually, it's an example for the combination reaction where the calcium oxide and the water combines together to give a single product that's nothing but a calcium hydroxide. calcium hydroxide, that is CaOH twice, calcium hydroxide. Okay, so this is an important reaction that you will be learning, and along with this a large amount of heat energy will be liberated, hence we also call this as a exothermic reaction. A large amount of heat energy will be liberated and two reactants are combined together to form a single product, hence it is a combination reaction. It's a perfect example for the combination reaction. Okay. Now, justify your answer by giving balanced chemical equation for the chemical reaction. Okay, where you will be defining the combination reaction where two or more different reactants combine together to give you a single product. Okay. That is a section B carries 2 marks. If you explain by giving the name of it, you will get 1 mark, and for the reaction, for the balanced chemical reaction, you will get another 1 mark where it is already balanced. Okay. Coming into the section C, write one chemical equation for each chemical reaction in which the following reaction takes place, like the change in color. Can you give me a reaction where you can find the color change? Of course, displacement reaction. Everyone will be going ahead with the displacement reaction, right? Can we give the example of iron dipping in the copper sulfate? Okay, let's go ahead with that. The first one. Iron. Okay, iron is dipping in the copper sulfate solution, CuSO4. Okay, we know that the color of copper sulfate is blue in color. Okay, copper sulfate is blue in color. Okay, we know that iron is more reactive than the copper. Iron is more reactive than the copper. So displaces copper from its salt solution, becomes FeSO4 and the copper. Okay, copper salt. It is aqueous and solid. Okay, becomes FeSO4. What is the color of FeSO4? Color of FeSO4 is really simple. It's green in color. Okay, as I told you, it's called as a green vitriol and this is called as a blue vitriol. Okay, so FeSO4 becomes green in color. Okay, and the copper will be depositing over there, which will be having the reddish brown color. Okay, so this is a reaction where they can observe the color change. It is transferring from blue to green. It's a color change. Okay, so that's an example for the first one. Can we come into the second one? Change in the temperature. Can you give the example of the example that I have given in the last question? Where the calcium oxide reacts with the water. Calcium oxide reacts with the water. We'll get the calcium hydroxide along with a large amount of heat energy evolved. You can give the same equation or else you can give, shall I erase this? Okay, or else you can give the neutralization reaction where the NaOH and the HCl reacts together so that we will get the NaCl, salt and the water. Okay, neutralization reaction. Okay, salt and water will be produced. Again, this is a perfect example where the heat energy will be evolved and the heat energy will be increased. Okay, you have to mention the color change or the temperature change. Is it rising or falling? The temperature will be increased during this chemical reaction. You have to mention that. Okay, everything carries a mark, you know. Now coming into the third one, formation of the precipitate. Okay, can you give the example of potassium nitrate KNO3? No. This is a perfect example that we can give where the lead nitrate is reacted the 2K iso. We'll be writing 2 right over here, and the PbI2, which was nothing but a yellow precipitate. Okay, which is nothing but a yellow precipitate, which is a yellow precipitate. Done. Okay, so that's again an example for the displacement reaction itself, a double displacement reaction. Okay, a double displacement reaction where the precipitate will be formed and mention the color of the precipitate is yellow in color. Okay, done, done. All right, now let's go ahead with the next question that we have. Again, carries the 3 mark itself. Okay, pH of sample of tomato juice is 4.6. How is this juice likely to be tasted? Okay, give reason to justify your answer. Tomato, the pH is 4.6. Okay, coming into the pH, you have to importantly note one thing, that if the pH is 7, it indicates that the solution is neutral in nature. Okay, the solution or the like whatever solution is neutral in nature if the pH is 7. If the pH is anything lesser than 7, okay, if the pH is lesser than 7, it will be acidic in nature. It will be acidic in nature. If the pH is greater than 7, if the pH is greater than 7, it will be basic in nature. It will be basic in nature. Okay, now it is below 7, it's 4.6, that indicates that it is below 7, it's acidic in nature. If it is acidic in nature, what is the taste? Acids will be having the sour taste and the bases will be having the bitter taste. Okay, since it's acidic in nature, it will be having a sour taste. Now, likely to be taste, it is sour in taste. Okay, it is sour. Give the reason to justify your answer, because it's acidic in nature and the taste of the acid will be sour in nature. And if you want, you can also mention what is the acid present in the tomato. What does it? It's the oxalic acid, correct? Tomato will be having the oxalic acid present in it, so it's sour in taste. Coming in a second, if you write this much, you will get the 1 mark. How do we differentiate between the strong acid and the weak base in terms of the ion formation in the aqueous solution? Okay, if you take an acid and dissolve it in the water, I'm going to erase this, okay? If you take an acid, for example, HCl, okay, HCl, mix it in the water, it completely dissociates into H plus and the Cl minus ion. Okay, if the acid or any base, it's completely dissociating, that is called as the strong acid or the strong base. Okay, if you dissolve it in the water, if they completely 100% dissociate, we call them as the strong acid. Okay, applies for the base as well. Okay, for example, NaOH is a base where they completely dissociate in the water into Na plus and the OH minus. Okay, that's a strong base. Now, that's a strong acid. Coming into the weak base. Okay, if they partially dissociate, this example you can give for the strong acid. Coming into the weak base, let's talk about NH4OH. Okay, NH4OH is ammonium hydroxide. It's a weak base. When we mix it in the water, they only partially dissociate. That's NH4 plus and the OH minus. They partially dissociate into its ions. Okay, anything which partially dissociate into ions is called as the weak acid or the weak base. Since we had to talk about the weak base, explain it with the help of the examples. Okay, completely ionized, strong. Weakly or the partially ionized, that is your base. Okay, weak base or weak acid. Done? All right, getting into the next part. Section D. Define the homologous series of the carbon compounds. Homologous series. What are homologous series? Homologous series. Homologous series is a group or the family of compounds, group of compounds or the family of compounds which will be having the same chemical property and the same functional group, which only differs by one CH2 group or 14 unit mass. Okay, that's how you define a homologous series. Okay. Again, I explained in one of my revision sessions. So if you want the more details, kindly check it out. Now, why is the melting point and the boiling point of C4H8 higher than that of the C3H6 and the C2H4? They are the members. They are the adjacent members or the neighboring members of the homologous series. Correct? Homologous series of what? Alkenes with the ENE. Okay, alkene homologous series. Okay. Why do C4H8 have the more boiling and the melting point? Always remember that as the members increases by CH2 unit or 14 unit mass, okay, the structure will become bigger and bigger and bigger, right? And if they are like large compound, they will be having more intermolecular force of attraction, correct? So in order to break all the bond between them, we have to apply a large amount of energy. So we have the large amount of like melting point and the boiling point right over there. Okay, it's all due to the increase in the intermolecular force of attraction. As the members, as the carbon chain length increases, as the mass increases, intermolecular force of attraction increases. We require a large amount of energy to break all these bonds. Hence, they have the high boiling and the melting point. Okay, remember that. Why do we not see any gradation in the chemical properties of the homologous compounds? Okay, so boiling point and the melting point differs. Why not the chemical properties? Okay, I have already mentioned one thing, that they have the same functional group. What are functional group? Functional group are the group of atoms, or the atom, just an atom, or the group of atoms which defines the chemical property of the substance. Okay, if a compound have only one functional group, same functional group, the chemical property will be same, right? Because one functional group defines one property, right? That is the one which is defining the chemical property of a substance. If they have the same functional group, every members have the same functional group and the same chemical properties. Okay, are you getting my point? All right. So that's exactly what they have, the same chemical properties. Okay. Coming into the fourth one. Write the name and structure of aldehyde and ketone with the molecular formula C3H6O. This is the most important question that you can expect. Okay. Coming into the C3H6O, aldehyde and the ketone. Okay. You have to remember that aldehyde is a terminal functional group which always present at the end of the carbon chain, which can only present at the end of the carbon chain. Okay. It goes like this. C double bond O and the H. That is your aldehyde group, always present at the end of a carbon chain, a terminal functional group. Okay, and if it is the aldehyde, name should be ending up with the Al. Okay, the IUPAC nomenclature. We have to also name them, right? So aldehyde name will be always ending with the Al. Coming into the ketone, ketone is not a terminal functional group, always be in the middle of two carbon atoms. It cannot be in the end of the carbon chain. It should be always in the middle of the carbon chain. Okay, it is in the middle of the carbon chain. So it is in between two carbon atoms. Always remember that. Okay, C double bond O, there's no H. It's just the C double bond O between two carbon atoms. If it is the ketone, remember that the name should be ending up with the O-N-E. Name should be ending up with the O-N-E. Now coming into the formula, it is C3H6O. C3H6O, right? That means that we have three carbon atoms. We have three carbon atoms, correct? Three carbon atoms. Let's go ahead with the aldehyde now. Aldehyde have C double bond O H group. Okay, so it is terminal functional group. So let's add them up. Okay, now let's balance them by adding the sufficient amount of hydrogens. The valency should be perfect. Okay, where each carbon will get the 4 bonds around them. Okay, so that is your aldehyde. Meth, eth, prop. There are 3 carbon atoms, so the word root is prop, and the name it's propane. Okay, it's propane, right? 3 carbon atoms, propane, but E will be replaced with the Al just because it's an aldehyde. Okay, so the name will be like propanol. Okay, it's propane, replace E with the Al, propanol. Okay, now coming into the ketone, where we know that the C double bond O in between two carbon atoms. So understood that the ketone can be only present here. Now fill the valency by adding sufficient number of hydrogen atom. So that is the formula for the ketone, and we have to replace E with the O and E. So it's again goes with like this, propanone. Okay, propan. Okay, did I add two N over there? Okay, propanone. Done. What are these species called as? They have the same molecular formula but different structure, right? What do we call them as? They are the structural isomers. They are the structural isomers where they'll be having the same molecular formula but different structure. They are called as the structural isomers. Okay, so that will be giving you the answer for the section D. Okay, we'll go with the next one now. That is the OR question. We have an OR question right over here. Write the name and the structure of an organic compound X having two carbon atoms in its molecular formula, and the name is suffixed OL. The name is ending with the OL. What does that mean? What does that mean? What functional group might be there? Definitely OL indicates that it's an alcohol, right? OL, alcohol. Alcohol. If it is the alcohol, we know that OH must be there, correct? OH must be there if it is the alcohol. Now, it have the two carbon atoms. Since I don't have much space right over here, I'm adding a page and moving into the next. Okay, done. We have two carbon atoms and then OH over there. So, two carbon atoms and then OH. Okay, now let's fill the valency, say H2. So, the name of this will be ethanol, two carbon atoms. It is ethanol. We identified the compound. It is ethanol. It is ethanol. Okay. Now let's get back to the question. Name. Okay. Write the name and the structure. Done already. Now coming into this, what happens when X is heated with the excess of concentrated sulfuric acid at 443 Kelvin? Now we have to heat them up. Okay. We have to heat this 443 Kelvin and concentrated H2SO4. Okay, concentrated H2SO4 and 443 Kelvin. Okay, now what happens is really simple. Sulfuric acid. Sulfuric acid is nothing but your dehydrating agent. So role of H2SO4 is really important, which is nothing but it is the dehydrating agent which removes the water from the reaction. Okay, or ethanol. Okay, it removes the water. It goes like this. OH from here and hydrogen from here. Do you want me to draw the actual structure so that it will be much more clear than this? Okay, hold on a second. Here we go. It is CH3, CH3, CH2, and then an OH. Okay, this is how the structure of ethanol look like. Okay, now we are gonna remove. Which pen do we choose? We'll go with the blue. Okay, so OH from here and the hydrogen from here will be eliminated. The bond right over here will shift here. Okay, the bond between the carbon and the hydrogen breaks and shifts right over here. That forms a double bond over there. And let's remove the OH and the H. It's nothing but a water molecule, right? We are removing the water molecule and write down the rest of the product. Okay, so it's gonna be C, and we have two hydrogen left, so CH2. Okay, now this bond shift over here, which will be forming a double bond between. Okay, now we have C with the two hydrogen on the top, so CH2, CH2, CH2 along with the water molecule. So what is CH2, CH2? It's nothing but your ethene with the ENA. Okay, ethene, double bond. The name should be ending up with the E and E. Done. So that is your ethene. Now, what's the next question? State the role played by the concentrated sulfuric acid dehydrating agent. Name and draw the electron dot structure of the hydrocarbon produced in the above reaction. What is the hydrocarbon produced in the above reaction? It is the ethene. Now we have to name them. Name and draw the electron dot structure. Name them. It's ethene. Now let's draw the electron dot structure. We know that there are two carbon atoms and there is a double bond between them, which is nothing but the electron shared by the two carbon atoms. Okay, so is this visible? Do you want me to draw the bigger dots? Okay. Okay, 4. Now, this carbon atom will be joined with the two more hydrogen atoms and this one as well. Okay, so there are 1, 2, 3, 4, 1, 2, 3, 4, 4 electrons for one carbon atom. That's the valence electrons. Now let's change the color of the pen and draw hydrogen. Okay, hydrogen will be also participating in the chemical reaction by sharing one electron. Okay, so we'll draw the hydrogens as well. What's left? What is left? What do you have to do now? Just the circles. Okay, circles. You have to circle them up, and when you're making the circle, make sure that you give the proper one. Okay, so hydrogen with the 2 electron satisfy the valency, doublet rule. This hydrogen as well, this hydrogen. Okay, now be careful when you draw the circle around the carbon atoms. Okay, so it should be, I'll change the color of the pen. Let it be colorful. Okay, here we go with the yellow. Now goes like this for one carbon atom, and if you're confused, make sure that you count the number of electron around the carbon atom inside the circle. It should be 8. 1 2 3 4 5 6 7 8. That's correct. Okay, next let's go ahead with this carbon atom now. Okay, so 1 2 3 4 5 6 7 and the 8. So this will be the electron dot structure for ethene. Electron dot structure for the ethene. Okay, done. We'll go to the next question. That's it. Now, section E, which will be having the 4 marks, okay, which will carry the 4 marks. Read the question. Do you want me to read out? Do you want me to read out? Not that an important part, right? So I'm just skipping the passage. You can read it by yourself. I'll go with the questions. Okay. What is the cathode and the anode made up of in the refining of the copper by this process? Okay. It's the electrolytic refining of the copper. Electrolytic refining of the copper. Okay. So we'll draw the diagrams and explain. Do you want me to go with the diagram? Do you want me to go with the diagram? Or just explanation? Okay, so I'll just explain and go because we are running out of time, I guess. Okay, cathode and the anode. Okay, not satisfied with the going out like that. I'll draw the diagram. Okay, so we'll be taking the beaker. Okay, we'll be taking the beaker in which we'll be having the 2 electrodes, in which you will be having the 2 electrodes. Okay, 2 electrodes. Okay, and it is the electrolytic refining of the copper. So both the electrodes must be copper itself. Okay, and the solution that you're gonna take is the copper sulfate solution. Electrolyte is the copper. Okay, now let it be anode. Let this be the anode and let this be the cathode. Okay, let this be the cathode. We know that cathode is negatively charged and anode is positively charged, and cathode will be connected to the negative terminal of the battery. Sorry. Okay, it should be negative terminal of the battery and the positive terminal is connected by the anode. Okay, done. Now, what are you taking as the anode? Anode is nothing but your impure copper. Okay, anode is nothing but your impure copper and cathode is nothing but your pure copper. Okay, pure copper rod and this is your impure copper rod where you have to extract the copper from this rod. Okay, from the anode you have to extract the copper. We have to maximize the amount of copper. That's it. Okay. Now when the electricity passes, we know that the copper sulfate is our electrolyte which will dissociate into Cu2 plus and SO4 2 minus. SO4 2 minus. Okay, Cu2 plus and the SO4 2 minus. So we understood that there is a lot of Cu2 plus ions. Cu2 plus ions in the electrolyte. There are a lot of Cu2 plus ions in the electrolyte. SO4 as well. I'm not drawing it, which is not that important here. Okay, so Cu2 plus ions are there in the solution due to the electricity passed. Okay. Now we know that cathode is negatively charged, anode is positively charged. Correct. Anode is positive, cathode is negative. Or positively charged species attracts each other. Now, coming into the Cu2 plus. Cu2 plus is positively charged, attracted towards a negatively charged cathode. So, and comes. Okay, Cu2 plus will be accepting 2 electrons. I'm sorry. Where did I say? Cu2 plus will be donating 2 electrons. Okay, will be donating 2 electrons so that it will be gaining. Sorry. Becomes copper, it becomes copper solid, okay, and deposits on the cathode rod, deposits on the cathode rod. Reach a certain point, when they reach a certain point, all the copper sulfate will drain out over there because all of them gained like 2 electrons and they deposited on the road. At a certain point, or the Cu2 plus will be finished up, right? at the time. Okay, so always remember that, equivalent amount, we have the copper rod right over here, right, an impure copper rod which will be having the copper 2 plus ions as well, okay, which will be donating 2 electron. Okay, the copper right over here, will donate the 2 electron and becomes Cu2 plus. Okay, so will donate the 2 electron and become Cu2 plus, and equivalent amount of Cu2 plus will fall into the liquid. Okay, so that all the Cu2 plus will be converted into the rod. Okay, everything will be converted to the copper which deposits on the cathode, and as the time passes, the cathode rod will be increasing in thickness, and as the time passes, the anode will be like losing every copper ions, right, and it will become thin and all the impurities will come and deposit at the bottom, which will be calling as the anode mud. Okay, so this is the explanation that you have to give, not this detailedly, but still. Okay, so I hope you understood the mechanism behind this, which we have already learned in the revision classes, correct? So that's a brief about this. Now the question is nothing but what is the cathode and the anode? Cathode is nothing but your pure copper and anode is your impure copper. Okay, name the solution used in the above process and write its formula. It is the copper sulfate with a formula of CuSO4. Now coming into how copper get refined when electricity is passed in the electrolyte cell. When the electrolyte is passed, copper sulfate decomposes into Cu2 plus and SO4 2 minus, where Cu2 plus accept 2 electron and become copper solid and deposits on the cathode. Whereas in the anode, an equivalent amount of Cu2 plus will be formed by giving out 2 electron and fall into the electrolyte, and which is again deposits on the cathode. And at the end, the impurities will deposit at the bottom, which will be calling as the anode mud. Okay, that's about these questions, and if you write this much, you will get the 4 marks. Okay, and you have an OR question for the second part. Okay, if you are getting confused with the refining of the copper, or you feel like I can't do it, you have an option to go ahead. That is for the 2 marks. Again, only the third part. Okay, only the third question have the option, not everything. Okay, now coming into your question, you have 2 beakers given A and B. You have 2 beakers given, that is A and B. Okay, containing the copper copper sulfate solution. Both of them have the copper sulfate. Okay, both of them have the copper sulfate. Okay, what's next? What would you observe after 2 hours if you dip a strip of zinc in the beaker? Okay, you have dipped the zinc over here. Okay, zinc over here. And the strip of silver in the beaker B. Okay, beaker B, you have silver. What's the observation that you will make after 2 hours? Okay, so it is zinc and the copper sulfate. It's silver and the copper sulfate. We'll write the reactions. Okay, zinc and the copper sulfate. Then you have the silver and the copper sulfate. Silver and the copper sulfate. Okay, what happens now? Zinc is more reactive than copper. We know that. So displacement reaction will take place. That is zinc SO4 and the copper. Zinc SO4 and the copper. Now Ag and the copper sulfate, where AgSO4 and the copper will precipitate out. Okay, copper Ag. Sorry, no reaction takes place. No reaction takes place over there. Okay, no reactions. Why there is no reaction? Okay, how can you make that mistake? Okay, so there is no reaction because silver is the least reactive metal than the copper. When we compare the copper and the silver, what happens? Silver is the less reactive than the copper. Will there be a displacement reaction? No, never. There's no displacement reaction right over here. So no reaction, but coming into the zinc is more reactive than the copper. So zinc sulfate and the copper color is really important. You have to mention the color, which is green in color, and the zinc sulfate is colorless. Okay, it's colorless, guys, colorless. Okay, so that's about this 2 mark question. Okay, you don't have to draw the beaker and everything. No, just the reaction. Okay, so mention that green color turns into colorless solution. Okay, and it's a displacement reaction, where here there is no displacement reaction just because silver is less reactive than the corporate. That's it. Okay, so that's about the question paper 2024 set 1. We'll discuss the set 2 in the upcoming session. Okay, now I hope every part of the chemistry is clear for you, and if you have any doubt, just drop it in the comment box where I'll be answering every questions. Okay, I after the live as well, I'll be keep on checking the chat box. If you have any doubt, just drop it over there. I'll check it out, and have a great day ahead. Study well, be well prepared for the boards, and wishing you very all the best. Okay, and thank you so much for being here with us, and stay tuned with the Go Score.